Ever wondered how your phone's voice assistant or smart speaker just knows what you're saying, even in a noisy room? Or why self-driving cars can spot pedestrians they've never seen before? The answer lies in a fascinating AI phenomenon called benign overfitting. Let's start with a paradox. Why do some machine learning models excel at tasks far more complex than their training data? It's like a chef memorizing a recipe book, but then crafting a five-star meal no one has ever tasted. How does that happen? Here's the secret. Neural networks, those layered webs of math that power AI, can overfit their training data. That means they memorize every detail, like a student cramming for a test. But here's the twist. They still ace the exam. This is benign overfitting, when a model gets perfect on training data but still performs great on new data. It's the AI version of cheating, but somehow it works. So how does this magic happen? A new study dives into two-layer neural networks with leaky ReLU activation, a popular AI architecture. Researchers found these models don't just learn patterns, they converge in a specific direction during training. Think of it like a compass. No matter the path, parameters, the numbers defining the model's behavior point toward an optimal solution. The team used gradient descent, the algorithm that tweaks parameters to minimize errors. But here's the twist. They paired it with exponential loss, a specialized error metric. This setup let them track how parameters evolve. Previously, similar results were only proven for smooth, continuous gradient descent. This study shows it works even with a real-world, step-by-step version. And here's the kicker. They found conditions for benign overfitting. If the data isn't too messy or orthogonal, meaning features aren't completely unrelated, the model can overfit training data without hurting performance on new data. They even discovered a phase transition in test error, like a tipping point where performance suddenly improves. This isn't just theory. The findings apply to sub-Gaussian mixture models, which are everywhere, grouping people by height, income, or predicting weather. This means the research could help build AI that handles real-world chaos, like noisy sensor data or incomplete information. This study is a game changer. It challenges old ideas about overfitting and explains why deep learning works so well, even when models are way more complex than their data. It's like finding a hidden rule in a game that explains why the best players always win. So next time you interact with AI, remember, behind the scenes, it's not just memorizing data. It's chasing a direction, navigating complexity, and somehow getting it right. Thanks for watching. Drop a comment below. What's one AI mystery you'd love to see unpacked next? Let's keep exploring the future of machine learning together.